We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Of CaleyHamilton theorem, so that will be the very good theorem. So this is a CaleyHamilton theorem. And its statement is like this. So it's a very good theorem, and examples can be asked. Statement is like this: every square matrix satisfies its own characteristic equation so it's a very good theorem. What it says like this: suppose you are having a 3 by 3 matrix, and suppose for that matrix the characteristic equation is, say, suppose lambda cube minus say 5 lambda square plus say 6 lambda minus say 10 equal to 0. Suppose this is the characteristic equation. Then this theorem says that matrix satisfies its own characteristic equation. That means we must have a cube minus 5 square plus 6a minus 10i, and that is a 0 matrix. That will become a 0 matrix. That is the thing that theorem says. Okay, so let us have an example. See, by using this theorem, we can have the inverse, we can find the inverse. So that is one thing. Then the other thing is we can find the A inverse if determinant A is not 0. We can find the higher powers of A also. Okay, so if you multiply the this equation by A inverse on both sides, we can find the A inverse. Okay, and we can find the higher powers of A also. So let us have an example. So let us solve one example. Verify CaleyHamilton theorem for the following matrix. Hence, find A inverse and A power 4. So here A given like this: 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. So now let us solve this example. If this kind of example asked in GTU, it will be of 7 marks. So A equal to 2 minus 2 1 minus 1 2 minus 1 1 minus 1 2. Now we need to find the characteristic equation. So the first step is characteristic equation. We know how to find. We are having either this determinant A minus lambda I 0, or we know the method is lambda cube minus S1 lambda square plus S2 lambda minus S3 n equal to 0, where S1 is nothing but trace of A meaning the sum of the principal diagonal elements. So that is 2 plus 2 plus 2, and that is 6. S2 is nothing but the sum of minors of principal diagonal. Principal diagonal elements. So that is equal to, now the minor of these 2, so we have these 4 elements. Now we have practice. So 2 minus 1 minus 1 2 plus minor of these 2. So this second row, second column is not there. So we have these 4 elements. Okay. So that is 2 1 1 2 plus minor of these 3. So this third column, third row not there. So these 4 elements be there. So 2 minus 2 sorry, this is this element is minus 1. So 2 minus 1 minus 1 and 2. Okay, and so this is equal to, this is 2 to the 4 and minus 1. So that is 4 minus 1. Second, again 2 to the 4 minus 1. Third, again 2 to the 4 minus 1. And so that is equal to 9. S3 is determinant of A, and that is equal to determinant 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, and so this is equal to 2. We can find the value of determinant. So these 4 elements are there, and that is nothing but 4 minus 1. Then minus this minus 1, so that is minus minus plus 1. And so here these 4 elements are there, minus 1 into 2 minus 2, and minus minus plus 1. Plus 1. So these 4 elements are there. No, sorry. Plus 1. So these 4 elements are there. So that is 1 into 1, minus 1 into minus 1, 1, minus 2. And that is equal to, this is 6, minus 1, minus 1, and so that is 4. And therefore characteristic equation is lambda cube minus s1 lambda square, and s1 is 6, so minus 6 lambda square, then plus s2 lambda, s2 is 9, so plus 9 lambda, and then minus s3, and s3 is 4, so minus 4 equal to 0. Now by CaleyHamilton theorem, this the matrix satisfies this characteristic equation. Okay, so CaleyHamilton theorem is this characteristic equation. So matrix satisfies the characteristic equation a cube minus 6a square plus 9a minus 4i, and that is equal to 0 matrix. But here we need to verify. So we need to verify, meaning we need to do this process. So we need to find a square, a cube, and we need to keep here in the left hand side, and we have to verify whether that is 0 matrix or not. So for that we need a square. A square product of two matrices A, so that is 2 minus 1 1, then minus 1 2 minus 1, then 1 minus 1 2, and again A, so 2 minus 1 1, minus 1 2 minus 1, 1 minus 1 2. So we need to take the product, and that we know how to do the product of two matrices. So I want the first element, that is A11. So I need to take the first row, first column, corresponding element multiply, and then add. Okay, so that's not difficult. So that is nothing but 2 2s are 4, this and this, then plus minus 1 minus 1, so that is 1, then plus this 1 1. Okay, now the next element is here 1 2, this element is 1 2, so I need to take the first row and second column. Okay, so this element is A12, so first row second column. Okay, so let us consider that part, first row second column. So 2 into minus 1, so that is minus 1 minus 2, then minus 1 into 2, so that is minus 2, then 1 into minus 1, so that is minus 1. Okay, next is this element is A13, that means first row third column 1 3. Okay, so let us take this one, 2 into 1, so that is 2, then minus 1 into minus 1, so that is plus 1, then 1 into 2, so that is 2. So we need to do the same thing for every other element. So let us quickly now. So second row first column, and that is minus 2, then minus 2 and minus 1. Okay, then here second row second column, here second row second column, corresponding element multiply and add. So 1, then 2, and then 1. So this is second row second column, so this is 1, that is 4, sorry. Okay. Now second row, third column here, second row, third column. So this is a -1, then -2 and -2. Okay. Now here third row, first column. So this is 2 plus 1 plus 2. Here third row, second column. So this is -1 -2 -2. Then here third row, third column. So 1 plus 1 plus 2, and so we are having 6 minus 5 5, then -5, then 6, then -5. This is 5 -5 and 6. So this is our a square. Let us find a cube. So same way we find a cube. So a cube is a square into a, and so 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6. This is a square. And now a. So 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2. So now we can find a cube. So this entry now we need to find first entry, first row, first column. So now it is easy. First row, first column, corresponding element multiply and then add 6 into 2 minus 5 into -1 5 into 1 kind of things. Okay. So that is nothing but 6 into 2, so that is 12, then minus 5 into -1, so plus 5 and 5. Okay. Then first row, second column, so that is -6 -10 -5. Then here first row, third column, so 6 plus 5 and plus 10. Okay. So this is 22 minus 21 and 21. Okay. Now here second row, first column, so that is -10, then -6 -5. Now here second row, second column, so 5 plus 12 plus 5. Then here second row, third column, so -5 -6 -10, and so we are having -21 22 and -21. Now this entry, third row, first column, so this is 10, then plus 5 and plus 6. Then here third row, second column, so -5 -10 -6. Then here third row, third column, so 5, then plus 5 plus 12, and so we are having 21 -21 22. This is our a cube. We need to take care there should not be a mistake. Now we need to verify, so we should take this side. Okay. So let us take this one, a cube minus 6a square, then plus 9a minus 4i. So a cube 22 minus 21 21 minus 21 22 minus 21 21 minus 21 22. This is a cube. Minus 6 a square. A square we are having 6 minus 5 5 minus 5 6 minus 5 5 minus 5 6, then plus 9a. So 9a is 2 minus 1 1 minus 1 2 minus 1 1 minus 1 2, and minus 4i. So minus 4 1 0 0 0 1 0 0 0 1. And so let us take the, so this is 22, then this is 6 but multiply with minus 6, so minus 36, 2 into 9, so 18, and 1 into minus 4, so this is minus 4. Okay, and we can see that this part is 22, 36 and 4, 40, and 22 into 18, 40, 40 minus 40, so it is 0. Similarly, we need to this one. Okay, so it's not difficult now. Minus 21, then plus 30 minus 6 into minus 5, then minus 9. Here there is 0. Then the third one is, so here also we can see this one is 0. Third one is 21, then this 5 into minus 6 and 9 into 1. So this is 21, then minus 30 and plus 9. And so that is also 0. Okay, next here minus 21, then 30, and then minus 9, that is also 0. Now here this second one and this also, so 22, then minus 36 plus 18 and minus 4, so that is also 0. Then next is minus 21 plus 30 minus 9, so that is also 0. Third one here, this one, this one, this one, so this is a 21, then minus 30 and plus 9, so that is also 0. Then minus 21 plus 30 and minus 9, so that is also 0. Next is 22 minus 36 plus 18 minus 4, so that is also 0, and so it's a 0 matrix. So therefore matrix A satisfies its own characteristic equation. So therefore CaleyHamilton theorem is verified. Now we want inverse. So now, so what is that? So a cube minus 6a square plus 9a minus 4i is a 0 matrix. Now we multiply both sides with the A inverse. So next is multiply by A inverse. So then we have here A square minus 6a plus 9i minus 4 A inverse, and we multiply 0 into A inverse, 0 matrix into A inverse is also 0. Okay. So A cube A inverse is A square. A square A inverse is A inverse is I. Okay. And I A inverse is A inverse. Okay. So therefore this we can take it on right side. So 4A inverse equal to A square minus 6A plus 9i, and therefore A inverse equal to 1 by 4 A square minus 6A plus 9i, and therefore A inverse equal to 1 by 4 and A square. So we have A square, and A square is 6 minus 5, 5. Then minus 5, 6 minus 5. Then pi minus pi, 6. Then minus 6, A. So A is 2 minus 1, 1. Then minus 1, 2 minus 1. And then 1 minus 1, 2. Plus 9i. So 9, 1, 0, 0, 0, 1, 0, 0, 0, 1. And so this we can easily now find 1 by 4. This is 6 minus 12 plus 9. Okay. So 9 plus 6, 15 minus 12. So this is 3. I leave to you that this you can do easily. It's not difficult. Then minus 5 plus 6. Okay, minus 5 plus 6. So that is 1. Then 5 minus 6. So it is minus 1. Then minus 5 plus 6. So this is 1. Then 6 minus 12 and plus 9. So that is 3. You can easily find minus 1, 1 and 3. So this is our A inverse. Next we want to find A power 4. So again, now A cube minus 6A square plus 9A minus 4I is 0 matrix. So we multiply by A. So then we have A power 4 minus 6A cube plus 9A square minus 4A, and is 0, and therefore A power 4 equal to 6A cube minus 9A square and plus 4A. So this is A power 4 equal to 6, and here you put A cube, and A cube we know A cube is 22 minus 21, 21. Then minus 21, 22 minus 21. Then 21 minus 21, 22. So this is A cube minus 6 minus 9, sorry. So minus 9. A square. So a square is 6 minus 5, 5. Then minus 5, 6 minus 5. Then 5 minus 5, 6. And plus 4a. So that is nothing but 2 minus 1, 1. Then minus 1, 2 minus 1. And then 1 minus 1, 2. So friends, I can just leave to you this one, multiply this one, this one, this one, and just you add all these things. You will get easily the answer. Okay, so I just leave this part, and then you can solve this as 86 minus 85, 85 minus 85, 86 minus 85, 85 minus 85, and 86. Thank you.